Yeah, I was the first guy to use the new restrooms, and boy, were the workers mad.
You're dangerous.
So we've got our usual crowd here, and then I think the phone number is from Kevin Catelli, who's with the Army Corps of Engineers, interested in our project and wanted to listen in today.
Yep, I'm here, and I'm calling in. Can you hear me?
Yes.
Yes.
Yep.
Oh, okay. Good.
Welcome.
Okay.
Welcome.
Okay. Glad to be here.
Well, I think we'll go ahead and get started. That's okay. We're going to have Jan and Mike give us an of the 30% design, where they are at this point. And most especially, we're going to talk about the costs of each of the elements of the project. We started a conversation yesterday, which kind of blew us on the town side away because we found that we were a long ways off from the budget. But as we talked later with our cable connection, so we lost several people, and then a few of us were able to continue the conversation. And during that part of the conversation, we talked about some ways in which we could tighten up the budget and hopefully make it workable and everything we want, but probably not to the same degree of what we had originally hoped for. And I guess that's not unusual for anybody's budget. When you start out thinking you could get the Lexus or the Cadillac, and you end up with the Buick or the Chevy. So since my connection seems to break up quite a bit, I'm going to rely on Jan to do most of the talking here. So hopefully you're able to hear me in that little intro. But we have most of our committee members here today. Got a couple guests joining us, and then it looks like Mike and Jan from our consulting team. So Jan, do you want to go ahead?
Sure. Thanks, Matt. Yeah, Mike Zarba is here with me. He's with SLR, and we are hopefully we'll be joined shortly by Jason Williams, who's the landscape architect with SLR too. We've got a short presentation that I'd like to run through, if that's all right with folks. To make things go smoothly, if you could put your screen on mute, that'd be great. And we can certainly take questions at the end, and we can, if you have questions, feel free to put them in the chat. I've noticed there's already one item in the chat. Okay, so why don't I start? I'm going to share my screen, Matt. I might need your permission to do that. Okay, and I'm going to run through our presentation. Let me know if it shows up correctly here, because I've had issues with
It is showing up. Yeah.
It is.
Okay. And did the screen just change?
Yeah.
Good. All right. So what I wanted to do is start today with basically review our project goals, because I think it's important to kind of look at that as a foundation for where we're at. And as you all know, the project, one of the principal project goals here is to provide flood protection for the downtown buildings adjacent to the parking lot, and to remove those buildings from the flood zone. This would also have a secondary benefit of protecting some key infrastructure, namely the pump station that's down there and other facilities. Also provides public safety if we can take the parking lot out of the flood area, where you wouldn't have that interaction between the flooded area and potential for cars and other vehicles in public. The parking lot, the idea there was to enhance the parking lot surface and also not lose any or lose a minimal amount of spaces in this whole in the project. And then as far as managing stormwater runoff, we were going to provide flood control storage. So if we had one of these flooding events and water couldn't drain off the parking lot, we'd want to make sure that we'd be able to accommodate the water that would occur from runoff adjacent to the parking lot and within the parking lot. So we wanted to prevent stormwater backing up and provide some level of treatment before it gets discharged to the river. And there was another ancillary benefit or ancillary goal here was to maintain or to enhance the park where we could by incorporating a living shoreline and doing some other enhancements to the park, maintaining access to the park. It was an important element for the downtown. So just to review, the flood zone is in the picture on your screen, and it shows the parking lot and the backs of several buildings being inundated or within the flood zone itself, the current FEMA flood zone. And there are other, this is the current FEMA flood zone, and then there are other concerns related to sea level rise, wave run up, and what mitigating effects the living shoreline might have on that whole process. So those are all items that have gone into consideration in arriving at some of our design. And this is a slide you've probably all seen before as well from our previous presentations, but I wanted to reiterate it because I know there was some concern over the height of the wall, and that being somewhat of a concern from an aesthetic perspective. And so I wanted to revisit this slide briefly to look at how we arrived at that 13.1 top of wall elevation for the current condition, with potential for the future to manage sea level rise to increase that to 14.6. So the FEMA, we worked with FEMA to both understand how their model was derived, where their flood elevations were at, what kind of factors of safety we needed to apply to various levels. We had wave run up. We have factors contributed that the wall itself contributes to additional height because of being able to control waves as they hit the wall. And what we arrived at was a flood elevation of around 12.6 that we had to meet. And then with concerns from sea level rise, we bumped that up to 13.1 for a commit to manage sea level rise, which was the recommendation from the state. And then in the future, we looked at managing that or being prepared to manage a sea level rise that would take that elevation up to 14.6. And so that's kind of how we arrived at the particular wall configuration. So our concept is a flood wall to elevation 13.1 that runs along the back side of the park and between the park and the parking spaces, around the pump station, across the boat ramp, along Misery Gulch, and behind, whoops, let me back up. Clicked on something behind the Alan McKinnon's building here and across the parking lot to Schooner Landing and then up to Main Street. And that's where the existing grades rise to elevation 13 or 13.1. Another component here was park improvements. The last time we met, we had discussed several different alternatives, and there was a pretty strong preference for alternative 1 or A that we presented, which was more of a natural type living shoreline with, you know, not as much hardscaping and so forth. The other thing we had discussed the last time was enhanced stormwater management system. So we had conducted some modeling showing what would happen if there was a 100-year rainfall event at the same time that the river was at a 100-year flood elevation. And we looked at how do we accommodate storing that excess landside water, fresh water, until we could discharge it through the storm drain system. So we developed an underground storage system. We had also looked at pumping as an alternative as well. The parking lot resurfacing has always been as part of the project. Pedestrian enhancement from Taco Alley and Water Street has been part of the EDA application, certainly, that we've been working with the grant funds. So we had discussed and presented several different wall options, and we had looked at at soldier piles with sheet piles. We looked at sheet piles with concrete walls supporting a concrete wall faced above. We looked at a sheet pile wall that was clad in a stone or faux stone type cladding to enhance the aesthetics of it. And we'd also looked at an option with a wood cladding on that. We've done some pricing of these options, and I've got the estimates underneath here for the concrete, precast concrete cladding on top of this wall. It would be about 1.6 million, and that's for a segment that's about 700, a little over 700 feet long, that would take us up to the Misery Gulch Bend, and all the way over towards the Water Street end. And the same, and there are differences in the cost depending upon the cladding. So it ranges from 1.5 for, let's say, a wood cladding, $1.5 million for that option, 1.6 for the concrete cladded wall, and then $2 million for a stone or appearance of stone type cladding on the wall. So that gives you an idea of ranges. What I'm going to do is I'm going to walk you through various components, showing you some costs for those components. I'm going to have a table near the end that we're going to look at what those costs ranges are and where we're at. And then we've done some work in the last couple of days to kind of how do we bring that down to something that's within the budget. And then one area here is we have $400,000 for just a concrete wall on the west side. I'm going to flip back to the previous slide if you'll excuse me for a minute. And that would be this piece here. We don't have any good geotechnical information here, so we're not sure if we're going to need sheet piling underneath that wall. And if we can get away with just a concrete wall to 13.1, that may be a cheaper alternative than driving sheet piles. The other we don't know yet, but that could also require sheet piling underneath it for support, and also to prevent tidally influenced groundwater from migrating behind the wall and causing the soil to fail on the inside of the wall during these high tide events. So we have a range here of 400,000 to $1 million if we need sheet pile underneath it. The other thing that we had looked at in reaction to some initial comments we'd seen wanting to have a more open or concern about the wall being almost 5 feet higher than the existing grades, blocking a lot of the views along the waterfront area, is we looked at, is there a deployable system that we could, that is out there? We found one that we could make into a walkway, if you will, and then as the water rises, that whole area would automatically hinge up into the upward position, and create your wall essentially during the flood condition. And then as the waters recede, the wall would then drop back down, and you could use that as a walkway again, which is a very elegant solution for that particular situation. The cost for about a 450-foot section is about 1.7 million. So you'd still need to have sheet pile walls or some other form of walls on either side of that to be able to marry into, but at least for the bulk of the parking lot, you'd have open view. Then we looked at gates. So we looked at gate systems, and from left to right, they vary in costs. There are going to be 4 gates. You've got 2 vehicle gates, one at Schooner Landing and one at the boat launch, and you've got 2 pedestrian gates along the park area. And so we looked at this automatic system that's very similar to that. That's the same system essentially as we just showed you for the walkway that could tilt up. And these are gates that you can drive over, and they're activated by water pressure. Hydraulic pressure from the rising water lifts them up. They float in the upward position. The vehicle openings would be about $150,000 in order to do that in each of the vehicle openings, and a pedestrian opening is about $300,000. So, I mean $30,000, excuse me. Then we also looked at large swing gates. These are hinged. They remain in place and can be deployed relatively rapidly. And these gates, they would, when you knew the flood is coming, you'd have to send somebody out to close the gates essentially. And for the vehicle opening, those are about $48,000, and for a pedestrian opening, it's about $22,000, depending upon the width. And then we also got another option that's a little bit more labor intensive, but less money certainly. It's about half the cost, less than half the cost. And these are aluminum stop logs that would have to be deployed when you knew the flood was coming. You'd have to send someone out, install the stop logs, and they actually lock in place with a screw mechanism at the top to keep them from floating, and to make sure they're securely against there's a concrete curb that runs along the bottom of both this and the swing gate options to make sure they get locked in place. And these would range for from about $24,000 for a vehicle-sized opening to $6,000 for a pedestrian opening. So that's basically the barrier system that we'd be looking at. Now we're looking at stormwater management. What we had looked at several options, but the most reasonable in terms of expense-wise that we had looked at was the on-site storage for water that would be draining to the parking lot during a flood event in the river. And we looked at accommodating a 100-year storm, a rainfall event, with no surface flooding at all in the parking lot. And we had come up with a underground storage system that would be about 45 feet by 300 feet or so within the parking lot. And it's about 2.5 feet deep of storage. And you could drive and park on top of the system. And with that, as well as the additional piping and manholes and other structures that would have to occur here, and replacement of pipes, additional pipes, we had a total cost of about $843,000, and that also included both treatment for floatables and other debris in the lines, as well as a filtration type component to the two outfalls that we have. So you would treat low flows, your regular storm events, you would treat the flows through a filter type system. So those low flows is where your bulk of your pollutant loads come from, would be treated through a filter system, which also requires ongoing maintenance. And then we had looked at rebuilding the parking lot. We were looking at removing the pavement, replacing gravel on some of the gravels underneath to create a better base, and then repaving with 4 inches of pavement and striping. So that cost for that particular component is about $800,000 for that scope of work. Then we looked at park enhancements, and what we looked at was incorporating the living, doing some work on the revetment that we have there within the existing rip-wrapped edge, creating some opportunity for some planting areas, and then also creating walkways and planting areas within the revetment areas to create the living shoreline. And then also there was a number of components for the park itself with seating, seat walls, benches, chairs, flagpoles, kiosks, other things that would enhance the experience there, as well as some additional landscaping. And the cost for that particular piece was about $220,000. So what this is our cost summary, where we're kind of adding up the overall cost range that we had just spoken about. And when the lower end of the range, we came up with about $3.82 million. And the upper range, depending upon what we went with, including that hinged wall and everything else, was approaching $6 million. So in speaking with Matt and so forth, the budget that we have for this particular aspect of the project is about $2.5 million. So there's quite a gap there. So what we had several discussions on how do we bridge that gap, and how do we get ourselves closer, and obviously it involves some level of compromise. And so what I don't have a lot of pictures, but I do have some suggestions, and I'll run down through the bullet points. So for the wall, what we looked at is doing just a straight sheet pile wall with a cap on top and no facing on it, thinking that in the future that sheet pile wall could be enhanced with other projects or in some other ways. The sheet pile itself is a roll form section, and it does have a coating on it, so that and because of the location, it's against the salt water, so there is a coating on it. So just so you're aware of that. We looked at then incorporating stop log gates using that particular method, which again is more labor intensive and takes a little bit more time, so a little bit more preparation before the flood. And you have to give yourself a little bit more time to activate or deploy that particular component of the flood system. And then the west wall, we're hoping that we could just do a concrete wall there. We're not quite sure exactly how that might turn out, but if we have to incorporate piles underneath it, that price could go up. Under stormwater management, again, the big concern there was the overall storage system. So what we discussed was, in our modeling scenario, we really chose a very risk-averse model where we'd have a 100-year rainfall event at the same time we're having, flood surges, high tides, and all this overlapping probability. So what we said is, what if we look at, a reduced or no storage at all. And then what would happen is we would end up storing some of the water on the surface of the lot. And there are a couple of buildings that would be impacted by that, namely I think the back entrance of River Grill, the Artsake framing, and that particular area. I'm not sure if Damariscotta Center would be, that may be one of the buildings. But we looked at that and then we said, well, let's do that and then flood proof the buildings. So if we would have flood proofed those buildings, that would keep the water out of the buildings themselves. And it would be a very relatively short duration flooding event. It just would go out when the tide cycle would return back. So from that perspective, it would be a minor thing. The other thing we looked at is well, let's provide treatment for floatables, oils, and things like that, but eliminate the other filtration component of the treatment, because that's a relatively expensive and ongoing expense item as well. Then we looked at the parking lot and we said, well, what if we just reclaim it, meaning grinding it up and repave it? And we had an expense there of about $400,000 that brought that down about half. And then at the park, what if we were going to incorporate just essential items that would be difficult to do once the wall is in place, such as the work along the wall, along the water's edge to create the living shoreline pieces of it, plant some basic plants in there to establish themselves, but hold off on the park enhancements themselves, other than maybe some walkways. We don't need to buy all the furniture or the kiosks, things like that, and trying to bring that price back down to just essential, what I would say essential work to incorporate that particular item in the scope. And our budget now is around 2.68 million, so we're still a little bit above the town's budget goals. So we have some more whittling to do, and there may be some other, some more examination of some other potential options. But in the time frame we were given, this is what we were able to arrive at. And I don't know if Mike, if you have any other things to add, Mike Zarba, but.
Jan, you've covered basically all the things that we've looked at today. The sheet pile wall, would be one that we want to take a little harder look at in some of the, the landscaping items. But I think, you summed it up well in terms of what the options for reducing some of the costs include.
I have one question, Jan.
Yes, George?
Do these numbers include engineering fees and contingency? Or are those going to be?
If you the town, it has asked for the engineering fees as that's a separate column as far as I know in the overall EDA piece. Matt, you can chime in on that. But.
It's a separate column. The 2.5 million was what I've calculated for construction only. So that doesn't include any other costs. And I do have and I could show you the spreadsheet I put together. I do have an additional 272,000 that I've put into a contingency column. So you're basically looking at 2.7 million that we'd have available.
But I think going into this process, you probably want to have some contingency. So
right,
we probably want to whittle this scope down a little bit further. But
yeah. Jan, can you explain what the sheet pile would look like without the facing? Would that just simply be a corrugated metal?
that's right. It would be a corrugated metal. It would, the sheet piles themselves, they're about 22 inches, or I think they're roughly 22 inches wide and about 10 inches deep in terms of their shape. So it's not like a corrugated roofing, but it's a much bigger, you know, I'm sure you're familiar with it. And these are cold form sections, so they're a uniform thickness. They don't rust like they wouldn't be a rusty type sheet pile like you'd see in a hot rolled section, if you will, or it would be more of it would have like a painted appearance to it. I was trying to look for examples of photographs of that earlier today, but I wasn't able to come up with something that I thought was a good representation.
Is the sheet piling steel?
Yes.
So historically, how does that hold up in marine environment?
Well, there is some degradation over time, and the sheet pile, when it's designed, especially if it's applied in the marine environment, you'll over design the thickness to allow for, you know, over time to have some corrosion occur.
So what thickness are we looking at for what corrosion time frame?
The thickness that this particular section that we're using here, I think it's about 1.79 or 0.179 inches in thickness. So it's less than 1/4 of an inch thick. It's a relatively lightweight piece of sheet metal.
Wow.
And how long would you anticipate that lasts under this environment?
Well, I think, Mike, I don't know if you've got a sense of that, but my sense is it's have a pretty long lifespan, but I don't know if Mike has
It
any-
certainly can. Obviously, facing it would have been, you know, certainly is the preference of trying to help protect it from those elements. I mean, generally speaking, though, it's not directly exposed to the salt water on a daily basis, but certainly it's in that environment, and it's gonna experience some corrosion over the years. Again, facing it would certainly be the preference to protecting it for the longer term, but I would see no reason why you know, a 30-year lifespan wouldn't be reasonably expected from this, and most likely longer. But I think the idea of this estimate was, you know, in talking with Matt and other members, that, you know, the goal would be to face it eventually. It's just that we wanted to get you a project that, you know, could be constructed today and meet your budget requirements, and then through future enhancements, that would be the goal of the town to, you know, further enhance it with these other components that help protect it more long term.
And does that also mean that the potential long-term use would allow you to add several inches, if not 1.5 foot of sheet pile on top of the existing sheet pile?
That's correct.
That is correct. You know, the structural capacity of it is being designed for that. I believe Jan showed a slide, but that 14'6" elevation is the max elevation that, you know, this particular wall, with the wave forces and the forces from the flood itself, that the wall can handle. But it's designed specifically to handle that height of water impact. Yes.
So just to clarify, so I understand what you said, in order to heighten the wall, you'd put sheet pile in next to this at a higher height.
Oh, you could
No.
weld it to the top of this.
Correct.
Or you'd weld it to the top.
attach it directly
Okay,
to this.
that depends on the structural integrity of what's there, and it's not being corroded by water and weather.
Well, I have another question. Going more than 30 years down the road, should the sheet piling deteriorate to a point where it's worrisome, is it possible to drive new sheetrocking immediately next to the old? In other words, having the corrugations nest to each other and simply drive it down? I would think it would be easier to drive it in those circumstances, because there'd be one smooth side relatively to the other. I'm wondering if that has ever been done, because I mean, ideally we should look to the longest term serviceability as we can.
And if
This,
if you're
yeah,
concerned
this
about
sheet piling will have some pinning, most likely. And we haven't got obviously that far in the detailing and specific structural design of it, but it will most likely require some kind of pinning, to hold it in place. Although that would generally be to one side of the wall or the other. So, could you drive it? I could certainly ask our structural engineer that. I don't, I can't see where it would be structurally as sound if that was the case. So I think you'd need to do something specifically in attaching it to, cutting back to a structurally sound piece of the steel, if that was the case down the road, and attaching from that point. But the wall height itself can be 14, to the height of 14'6", but it does need to be tied to that full length of structure, if that makes sense.
The corrosion that takes place on the metal surface is primarily, the worst part of it is above the part that is buried in the bottom sediment. Is that correct?
The highest corrosion area is going to be the area sticking above grade.
Right. So does that 30-year time estimate include the electrolysis that we're liable to see, because we've got all kinds of electric wiring in the vicinity of this wall?
I'm not sure about the electrolysis.
Yeah, I don't think we've gotten into any of that aspect of it. The whether that's protective coatings that could be applied or reapplied, over time. Some of those issues can be dealt with that way. So yeah, I can't say we have a better answer than as to what might happen to it from that standpoint.
There may be other options with regard to a cathodic type protection that you could bury the cathodic protection in along the wall to keep it from rusting as well. That may be another alternative we can look at as well.
Mike, what is your cost estimate for the exposed sheet pile option?
The exposed sheet pile option is 1.3 million.
And that is the cheapest option at the moment.
That is correct, yes.
Is there any possibility that some of the work the University of Maine's been doing with their coatings systems, we've talked about that off and on, have you looked into that possibility? I mean, they've done some pretty interesting work.
We have not looked into that coating system, no. I mean, probably the least expensive alternative, it would be to upsize the sheet pile slightly, so you have a thicker wall section, over design it, and that way it would have more sacrificial steel there for over time for corrosion. And
I guess what worries me is 30 years really isn't that long a span of time, and that's what worries me. I might not be here 30 years from now, but 30 years goes by pretty fast.
What is the estimated life of one of the other options that includes, the concrete or the rocks compared to the exposed sheet pile?
If it was protected with one of the systems that we've shown here, wood planking, stone veneer, or just a concrete stub out of the ground, there is some maintenance to be done on any of those systems as well, but properly maintained, I would see no reason why a 50-year lifespan and beyond is fully expected out of a system like that.
I have a question. It would seem that if you treated this like a bridge with an epoxy painted coating on it that could be rehabbed every so often, that would probably extend the life of sheet piling, and it would look good too, instead of all being a rust bucket.
I certainly wouldn't dispute that there's plenty of options and alternatives that can be explored to maintain it properly, to extend the longevity that you just talked about. Again, we're just, I think, trying to give you a pure, if you stuck it in the ground, left it in place, what would happen to it? If you maintained it, there's zero reason why you can't get longer lifespan out of it, with those protective coatings.
The other thing that I know that was talked about was to make openings in the wall for visibility. And I don't know if that's still a concern with the committee or not, but that's certainly a possibility with the sheet pile wall itself. There'd have to be some additional way to close that off with stop logs or something else. So we'd have to be mindful of that, but.
I guess it's fair to add, Jan, that any of those options are not included in the cost estimates. Those will be more expensive, but just to clarify for the rest of the committee.
Yeah, I know that Mike had some discussions with the structural engineers about this. And I'm sure it would add a little bit of cost. So I'm not sure how much, though. I don't know it would be huge.
Yeah, I don't think in our wall cost options that there would be tremendous difference whether there's an opening there or not, for the cost estimates we've given you.
When you were talking about the adding thickness to the sheet pile for reasons of longevity, I would assume that would only increase the cost of material. The cost of labor wouldn't be changed much, if at all, would it?
I would agree with you. That
I would too.
It might have a very minimal effect on labor, but because you're driving a slightly thicker metal through that soil, so it might take a little bit more time, but it is primarily in the material cost.
And is that a significant change in numbers?
Excuse me?
Is that a significant number change?
You typically pay about a square foot for the sheet piling itself. To go to a thicker section, although we'd certainly have to get you a better number, as to what the difference in, and it would depend on how much thicker it's going to be. But it can certainly add a few dollars or a couple of dollars a square foot to that cost, and you're looking at, roughly 730 feet of wall at 25 plus feet deep, where that sheet piling would be incurred. And just to get you a number on that, that's it's 18,250 square feet of wall. So at say $3 to $5, that's $50,000 to $75,000 in material cost.
I'm not sure that the public would react very well to this exposed sheet pile. So my question is this. It costs more, but can the wood version be viewed as temporary until additional funding or some other funding source is found, and then that could be upgraded to stone or some other brick or some other surface? Is that a possibility, or is this a one-way direction that you go with wood and then that's it?
Just that in order to move forward, I mean, we could certainly design it with a wood facing on it, but just realize that when it comes to construction, we'd either have to have the funding in place for that, or there would have to be some other compromise made in terms of alternative to drop something else to pay for that.
So how do we phase this then? That is to say, suppose we go without anything, just a plain sheet pile. But we look at raising the money so that 5 years from now, we can clean up the top. Is that the way can we think about it that way? Is there a logical, sensible way of phasing the project in that way?
I believe there is. I believe that.
Yeah, I would agree.
It's adaptable, so you could put something else on it. I mean, you could get precast concrete that you could attach to the wall. You know, you could have artist space along the wall as well, which may or may not, you know, be amenable, but in the interim to kind of dress it up some, a mural or something like that, painted mural.
So I'm just speaking for myself here. I've been thinking of this as a once and done project, and that was, of course, short range thinking on my part. But if we think of it as a phase project with several phases, we're talking about the first phase. How do we phase it so we get the long-term solution 5 to 10 years from now and know what we have to do money raising in between?
Well, I think the opportunity now with the funding you've got in place, I mean, my thought would be if you could put the wall in place, that's the heavy lift. I think the facing of the wall is, you know, it's more than just the difference between the 1.3 and the, let's say, the 1.6 or 1.5 for the wood, because you'd have to come back and you know, redo some things over slightly, but it wouldn't be a lot different from that. But I think the wall system itself would be adaptable to facing it with something other than just the bare metal.
And I think you've already said it's not going to be bare metal per se. There's going to be some coating on it.
It'll have a coating on it, yeah.
In terms of the public not being happy with the look of it, I'm not sure that's such a bad thing, because that would incentivize people to get on board and try to drive to raise funds to complete the aesthetics of it.
Hey, Jan, I've got a question, and it's not related to the wall, and you may want to wait to address that a little bit later, but it's getting back to the water storage within the parking lot and whether we can convince FEMA that we have an adequate means that buildings aren't going to get flooded by just internal rain and drainage, lack of drainage.
Right. What we're doing now is we are rerunning our models with a different rainfall events. So instead of using a 100-year rainfall event, using a 25 or a 10-year rainfall event, just to see what that impact would be. You know, if we could upsize some pipes that we're going to be replacing anyways to help mitigate or offset some of that storage or flooding, maybe we could do that. We're just looking at other opportunities now to see what level of water would be in the parking lot and where would it be, because the parking lot's not completely flat. There are low points. So we're trying to model those low points and figure out where, you know, what level of water there would be. So right now we don't have a definitive answer, other than we do know the sill elevations of some of the uses in that abut the parking lot. And so we know what the elevation, if we get to those elevations, those buildings will be impacted. So what we're trying to look at that as it's an ongoing modeling exercise. Again, we didn't anticipate that as of yesterday, but we started looking at it today. So hopefully we'll know.
That's
more.
good.
This is Steve. Oh, here I'm back on video. For the filtration, so I heard that there'd still be debris removal and floating stuff like plastics and oil could be stripped out of the water. But what's the part that was being lost in the intermediate solution?
Well, the other thing that would be taken out would be larger sediments like grits and things like that. In the stormwater itself, there's at times there are finer particles, such as other things that we would typically in an area we would put them through some sort of a filter, either like a rain garden type filter or some other type of grass under drain soil filter. But in lieu of not having the space, we've investigated other proprietary filtering systems that would sit in a tank, for instance, where as the water came into the tank, the low flows would be diverted into a platform where they would then go through artificial type filters, like these finger type filters you might have in your pool. And as it drains through that and then leaves, so there would be removals of these finer elements that might have some phosphorus attached to it or other types of pollutants.
So you're reducing some of the nutrient input as well through that.
That's correct.
Gotcha. Thanks.
How are these filters cleaned or serviced?
Yeah, that's the ongoing maintenance part of that, is that they have to periodically, they have to be pulled out, and either they're backwashed or they're replaced, taken away. You put a replacement in and then you backwash that someplace that you can capture those sediments. So that's how those are maintained, and the frequency of maintenance, it's really site dependent, depending upon what types of pollutant loads or sediment type loads you're getting in that particular area. A lot of the area around this, you don't have a lot of vegetated surfaces, so it's mostly very fine material coming off of cars or whatever dust may be coming into the area, that sort of stuff.
What's the performance history of these filters, of these storage systems with filters?
Well, the storage systems they're a separate. They've been around for a long time. They've been used for, underground storage of stormwater, for instance. That's fairly common practice. It's been common practice for the last 20 plus years, if not longer. The filter systems, some of those have been around for a little while, for another 15, 20 years as well. And again, it's very site specific depending upon what type of pollutant loads you might get in those areas. So, but they have been around for a while. I know that DEP has approved them for use for stormwater, for some benefits when it comes to stormwater treatment, things like that. So, but they do come with the ongoing maintenance.
Well, that is important. It's no secret that we've got a very valuable oyster industry not very far downriver from the parking lot and further down as well. And of course, that's a big reason for our concern. Not the only reason, but it's a very big one.
Well, yeah, and rightly so. So it should be, if we're investing that kind of money, or if you're investing that kind of money in your parking lot, why not go the extra mile and bring it up to current standards, if nothing else, with regard to stormwater treatment.
Could I ask a question again, getting back to the sheet piles in terms of their function? You mentioned that they were probably going to go that deep, and part of the reason being to counter the potential tidal exchange of waters under the parking lot. Is that correct? The sheet pile is going to perform two functions. Number one, it's going to provide support, because currently, in order to support, both the loading, once this wall is loaded with water on one side and nothing on the other side, it's going to provide vertical support, and then also through the granular layer that it varies
between, you know, up to 14 feet below the surface, this fill layer, which conducts water through it when you've got high water on one side and no water on the other side, it tends to force water through it. It's going to act as a cutoff for that particular, or for the water to get on the other side. And what happens when the water gets on this side, and it's under pressure, the surface gets very, very soft, and you know, you'll have failure in your surface. And so, and also not to mention that it provides it, you know, you lose your strength with your wall itself. So it provides two components. It's both vertical support as well as doing that cutoff.
Now that leads me to the question about your anticipation of hopefully getting away with nothing but the concrete wall going up the west side. Isn't it just as impervious there and just subject to water infiltration there?
We don't know that. We don't have any borings on this side or any borings in this area here. I know that the foundation was rebuilt underneath the building here at one point. And I'm not sure what was placed back in here, if it was all rock. If it was all rock, then obviously the water will move through there and that becomes an issue potentially. But up in this area, it might have been, you know, there may have been higher ground. I don't know where the native soils are. Because
well, I think it's fair to say that the southernmost western side of that, along the boat ramp and up towards the diversion to the south, is fill. So there's no reason to think that that would be any different than what's in the front, is there?
Well, in here, there's certainly, yeah, we've got some borings in here that do indicate fill along this edge here.
Right.
On this area here, I'm not sure if the native soils, we don't know where those native soils, what the
right.
other soils were.
I understand that. So are you saying that lower section that indicates there is fill there is considered as part of the steel effort right now?
Right now we're starting that here in this.
Okay, great. Thank you.
Down along here.
Ellen might be able to comment on any type of fill that was put in.
Yes, that space was empty. Our building was on pilings, and we jacked it in the air and bulldozed a fairly sandy, rocky fill in under it.
Right,
to what depth was that?
Even with the ground on either side, and it was mud flats under it.
So you really don't know how deep bedrock is under there?
No.
So that would tell me that any tidally influenced groundwater would tend to move through that soil underneath your building as the tides come up.
It might very well. Yeah.
I'm sorry I missed the first part of the presentation, but is there a comparison, a price comparison for the west wall concrete versus sheet pile? Or is the sheet pile impossible to insert there because of the buildings?
The sheet pile is certainly more challenging because of the disturbance of the pounding action, but it's certainly less so than if you were to put drive piles. I'm not saying that it couldn't be done, but it's one concern. The concrete, again, the overall comparison is the concrete wall is about 400,000 and that's without sheet pile underneath. If we have to put sheet pile underneath it, maybe we just make it a sheet pile wall. I'm not sure what that cost would be and eliminate the concrete above. But we can follow up on that. But the question is, do we have to drive sheet pile there? And to what extent, how far? If we have to come around the building with sheet pile and then convert to concrete, I mean, that certainly would impact some of the numbers here.
Yeah, I think to add to that, Jan, our structural and geotech engineers are a bit concerned about driving sheet pile there. So I think, we didn't necessarily want to do sheet pile there unless it was essential. And the reason you kind of see the cost differential there is quite large. Frankly, the sheet piling cost for that length of wall, which is a much smaller length of wall, is more per foot. And the reason it's more per foot is there's going to be other protective measures that have to go along with a contractor driving sheet piling in that location because of the effects. They have to protect the buildings. We have to do some pre and post surveys of those buildings. And of course, all of that does come with cost. So the idea was we were trying, frankly, to avoid having to drive sheet piling there because of the impacts it can have on those structures. And hopefully we won't have to do it. But as Jan said, we unfortunately weren't able to investigate that area in our geotech investigation. So we don't really know what's there right now. But it's something we'll have to investigate further if we choose that option. But I would suggest in that area, not just doing the sheet pile wall is not really the same option as it is along the parking lot and park area.
And I just, isn't the fundamental question at this point, how much problem would there be if water infiltrated along that west side versus, in other words, sheet pile versus no sheet pile? If you get water infiltration, is that a disaster or is it just a consideration to keep in mind?
Well, it depends. If that building is, I don't know if it's still sitting on piles or not, or if it's sitting on a regular foundation, then the soils underneath the foundation could get weakened during that action. There are other alternatives. You can put a grout curtain wall in, something like that, to help with that. There's other alternatives. So to sheet pile.
Yeah, I think it has to do with the designation. So the idea is to get these, if you're going to invest in the wall, you'll want it to get the buildings out of the flood designation zone. And to do that, we have to stop that infiltration. Otherwise, that particular area wouldn't be eligible for the letter of map revision, which is, again, Jan went back to the goals of the project. That was a primary goal of the project, was to get the buildings out of the flood designation zone. And I think if we don't stop that seepage, that would tend to probably exclude that area from becoming eligible.
So further testing will set the demand for whether it be a sheet pile or not, right?
That would need to be further investigated, correct? I think that's what I heard.
Will that further investigation, is that an extra cost to the project?
At this point.
Yeah,
Yeah.
I'm sorry, go ahead.
At this point, it would be. I mean, we've conducted the scope that we had actually didn't include that westerly loop, but we had looked at just coming up the side of that building to the street. But so at the time we were doing our geotechnical investigation, the town didn't have rights to go out there for us to do that investigation. So so we didn't conduct it then. We'd have to go back out and have another session out there. So
will you provide the town with a cost estimate on that?
we can do that.
We can do that.
Let me add one comment in. Matt, this morning, I think it was, you had mentioned you'd had a conversation with Scott Olson, who had met with Alan back a few months back. And he expressed some concerns about the opening that goes into his parking lot from the street. Is that germane to the conversation, or do you want to take that?
Well, so I spoke with Scott Folsom, who owns Schooners Landing. I think many of you know Scott. So that's the property on the Gulch from our parking lot. Oh yeah, there you go. And thought was maybe it's not in his best interest to put the wall where it's shown here. So where that letter A is, and then coming up, going to the left, and then up around the kayak shack. His thought was to make that closer to the Narragansett Leather building, that wall.
Yeah.
Concerned about the optic when he ultimately deciding our buyer is going to be concerned that the flood wall stops at his building. So, and there's no way to protect his building as we're doing with the buildings on the southern side of Main Street or Narragansett Leathers. There's no way because the structure of the building is on pylons. So with that, to answer your question, George, that was his concern, is the optics of, you know, what this gate looks like and the wall going across his property. So we may want to look at some alternatives to that, to how do we get out to Main Street with the wall.
Well, wasn't it also a concern that not only we get out to Main Street, but we go to the edge of the bridge in terms of
Yeah. Now, part of that issue may have been, well, I see Shari has her hand up too, but part of that issue may have been resolved for us. You know, when Jan and I were out there, I think it was on Thursday, we saw that the River House has built up their patio. We were thinking, from the town standpoint, we were thinking they were just going to put it on footings, but they've actually built a concrete structure there. So, you know, it may be something where we tie into that. We'll have to look at that more closely. But we, you know, yeah. So, Shari?
Has anybody from the fire department come out and taken a look to see how they would, for those buildings on the west side, how would they attack an aggressive fire? It doesn't look like there's a lot of alleyway or walkway to really approach these buildings. And I could have sworn like a while ago, somebody said one of these ideas didn't even offer at least a foot of space between the building and a wall. So, but I wondered, yeah, if we've had any fire department feedback.
I've talked to the fire department about it. They still have full access to both sides of Leather building and to Schooner's Landing under any of the scenarios we've talked about.
Okay, thank you.
Can we briefly go back to the discussion of the sheet piling extending above ground and its durability or longevity? I'm wondering if it's in the first drawing that we looked at of those three. I'm not sure if the concrete is sitting on the top of the sheet piling or if it extends all the way basically to the top of that concrete, which looks like the case in the other two drawings. But my question has to do with whether or not being embedded in concrete will extend the longevity, the lifespan of that sheet piling by not being exposed to the elements. I mean, if you can sidestep having to do some major upgrade in 30, 40 years, it might be worth the extra cost now to go to at least that length there. I mean, 1.6 million is a hell of a lot of money, but it's a big and important thing that we're doing. And that wall is really about the most important thing. Those are my thoughts, and that's my question. What embedding that sheet piling in concrete will do to the longevity of it.
I think the difference of the options are that it does encase it in a, not expose it to daily salt air and salt water spray. So the longevity of it clearly is enhanced from that aspect of it. I think the difference I gave you was basically about a 30-year lifespan to basically a 50+ year lifespan. I don't really think we can commit to anything further than a 50-year lifespan, but it's logical that there's maintenance to your concrete as well in that 50-year lifetime, or rock or stone, or even the wood aspects are gonna deteriorate and need to be replaced over time too. But you're gonna have to maintain any of the systems to some degree, the above grade part of the system.
Yeah, well, in my mind, it would certainly be a lot easier to aesthetically enhance the concrete wall. A lot easier than a corrugated steel surface. And that might be the phase 1 image we're looking at here, and going to Haas's phased improvements over time. It would leave room for some sort of enhancement, visual enhancement, as we go down the road.
Nick's got his hand up.
If we encase that in concrete, this is a question from a non-engineer. Do we get into a rebar situation where the rebar rusts and then blows out all the concrete?
No, you would use a epoxy coated rebar if you were going to use a concrete wall system like that. We would certainly suggest an epoxy coated rebar to avoid that particular situation.
The other possibility would be to have the concrete be precast panels that you'd set up against the, fastened to the wall, so that when you go to extend the wall, you could, pull that out, fasten the additional sheet pile or whatever you're going to use, and continue on up. But in any case like that, if it's precast panels against the sheet pile wall, you could always remove those, do maintenance if you had to. If it's the sheet pile wall coming up through with cast in place concrete on it, that obviously it's a lot more of a project to get out, and if you had something that you needed to do to the sheet pile. But
okay, thank you.
What I think in order to get the perspective of the committee is if we could do some level of prioritization. And Jan, if you could go down to that last slide that showed the bare bones object chart. It might be good to get from my standpoint is when I try to get additional funds for this project, it would be helpful for me to know what the priorities are from the committee. And I guess what probably a high priority would be if we're going to build that wall, to build it so it looks halfway decent, either with a concrete face stone facing. And here comments on the stormwater management. In our ideal situation, we're able to accommodate the runoff from a major storm as well as the tidal rise. But based on our prioritize, that may be a lower priority than some of these other items. So I guess I'd like to just hear some of the feedback on what on that list you see as the priority, and what are some of the additional items that should be added if we had the funds.
All right, my 2 cents is I would like the sheet pile to have facing, and I would also like a under stormwater management, I would like storage. So that's my first instinct for what I'm looking at.
Do you feel, Matt,
Okay.
that instead of just everybody weighing in now, that maybe we do up a little survey thing that everybody can sort of indicate?
Sure.
Where we can, I think that might be more helpful than people afterwards will go, oh, shoot, I didn't mention this or whatever.
That's a way of getting some sort of uniformity to our response.
Right.
Right.
Yeah, that's a good idea.
My priority is flood protection within the budget.
Yeah, I agree. From the very beginning, my primary motivation has been shielding the town from the rising water. The difficulty I have, the heartburn I have, is I looked at this, so much of this is interconnected that you can't dam off the town and not have a way to get rid of the water. So that's a bit frustrating, but I agree that a lot of those other things, the park and all that other stuff is very important, great ideas, but first and foremost, I'm concerned about protecting the town.
I believe that to be true too. I mean, the primary concern is safety, and the secondary concerns not that far behind, but the secondary concern has to be aesthetics.
Exactly.
So I, for one, think the sheet pile with facing, a faced sheet pile, because aesthetics are really going to kill us if we don't take some pains. And I would go with the swinging gates, which are less labor intensive than the stop log gates, and anything automatic, I just don't have faith that it'll work in adverse conditions, which we've talked about.
And we don't need to have that expense.
Right. And I don't know how critical the underground storage is. It sounds as though it could work, but all along we've talked simply about having duckbill valves on the end of the outfalls. No discussion of treatment of runoff or anything like that. So I guess we really ought to be exploring that underground storage. There's a lot of water coming down the hill, which we've been witnessing more and more lately. So we do have to do something about that. As far as the surfacing of the parking lot goes, I mean, I'm no stranger to using reclaim, but that would be something we could do temporarily. It could be repaved later. And the living shoreline is a wonderful idea, but actually what we got right now has been fairly durable. It's something we could enhance at a later time. Those are my thoughts.
Okay, good.
With respect to the underground water storage, how does the volume that we're projecting that could hold relate to the volume that will come down the hillside? In other words, if we have 2 inches of rainfall, does it fill that volume, that storage area? Does it fill it 5 times over? I haven't heard any numbers comparing what the runoff is to the possible storage capability.
Yeah, that's a good question. That's a good question. What we did is we modeled it, and in terms of, I mean, there may be other things we could do and slight enhancements that would direct any runoff that's coming from outside the area, outside the parking lot itself, there's one catch basin that sits up behind the post office that's up high enough so it shoots out before it the water from that shoots out outside of the parking lot itself. If we can capture and direct some and discharge it before it gets to the lower level of the parking lot, all the better. I'll look at that as well, but the storage itself, what we looked at is for a 100-year storm event, and having the tide be high and having the tide cycle go through the highest tide as this storm is happening and filling up, and having those, those peaks kind of coincide. The parking lot itself is a pretty good sized area. So if you get, a 100-year storm event, there could be 5 inches of rain. And most of that occurs over a relatively short amount of period. It gradually builds up. If you look at how the rainfall is the overall distribution's done, and most of it occurs in a less than 12-hour window in the center of that storm. So, but the tide cycle, that's also on a similar type time frame as well. So if the two coincided, you could see how they could cause an issue.
That storage system will be working all the time though, won't it? Not just during these big storms. I mean, every time we have rain, it'll enter that system and then find its way out.
Only if the outfalls aren't able to discharge.
Yeah.
It'll be elevation driven. If the tide is high enough to not allow water to leave the system, then that'll back up into that storage system.
So in 20 years of sea rise, that system will be ineffective.
Not necessarily. We've modeled it for the level of water that on the outside of the wall being up at elevation 12 or so.
Oh, okay.
And one thing, Jan, because there's no flapper valves at the end of the outfall pipes, and on a high tide, those pipes are always filled, and that's why the parking lot floods as often as it does. When you do have the flapper valves, you've got a certain amount of volume within the piping system in the parking lot. I don't know how significant that is, whether that makes a difference or not.
Yeah, and it really only comes into play, let's say, if the lowest surface in the parking lot is at elevation, it's just below 7.
Mm-hmm.
And if your tide is below that, water in theory would be draining out because you've got a little bit more hydraulic pressure on the parking lot side than you do on the river side. And it may not be able to flow out as fast as you need it to, and so there may be some temporary ponding. And once you put flapper valves on the outfall here.
Sherry has her hand up.
Thanks. On the log gates, those would be adjustable, right? We could keep adding to them if we needed to.
Yeah, the idea behind that is you'd have 5 feet worth of log gates or whatever the elevation needs to be. And I would think you'd want to deploy them when you knew a storm was coming.
Right.
If you knew it was just a smaller storm or you weren't as concerned, maybe you could put up half of them.
That's what I was wondering. Because if you have the gates though, it's an either or, is that correct? And when they're open, where do the gates go? I mean, are they still there as a visual?
They still are there, yes. Yep, they don't, because they're on a hinge.
And you wouldn't be able to add to the top of them eventually if we needed to?
Yes, you could.
Okay. Thank you.
Can I ask a cost question? The figures that you have up now, the options with the 2,680,000, does that include any kind of a contingency number one? And number two, what's the total amount of money that you have in hand currently, Matt, for the project?
So the 2.68 does not include contingency. It's what we think the construction would cost based on what we have.
And
typically we carry a contingency. I know, but Matt does have a contingency. I can let him speak to what that is.
Yeah, I have a spreadsheet. I could show it now that I'm looking at on my other screen. But if we take out here, I could put it on share screen. So, well, let's get share. All right.
It was there for a second.
There we go. So, you know, after we take out the, well, here I put the commitments. This is where all the money's coming from. This chart. Can you see the chart? I've lost my audio.
Yes, we can see it.
Yes, we weren't talking.
Oh, okay. All right. All right.
Trying to
Here,
be respectful.
okay. You could see the chart though, right? Okay. So this on the left-hand side is our funding source. Yeah, this will give you a gasp on what we're spending for the restroom when you include the cost of the land and the measures we had to take to build the floodplain. The towns on the salt bays, the sewer line, what we're anticipating the engineering is going to cost, and so then I give a balance of what's available, and that comes out to just under 2.5 million for construction, and not included in the any legal costs and a contingency. So if you were money that I think we'll have available, you're at 2.7 million if you add this figure to the contingency amount. So and that's, you know, what I think Jan and Mike have been working against, you know, to come up with the 2,680,000. Does that answer your question, Mike?
Well, I think it does. I'm confused by that 4.8 down on the left end there, or the 4.3, excuse me. What does that total amount mean?
That's all. That's kind of the revenue side of the chart that shows us we have. So there's a $3 million EDA grant, and to match that, we used a good chunk of the, or we're using a good chunk of the donations we received, and then there's additional donations and some tax money in the town sources. Great Salt Bay Sanitary District is contributing about 27,000 toward the sewer line, and of course they're getting a good deal out of that. And then Efficiency Maine is giving us some money to be used to the EV station, which is a fairly small part of the project. And so those are our revenue sources.
And so for the construction part, you engineers, do you have a percentage contingency fund that you usually recommend to your clients? So if we're talking 2.8, what would your contingency fund projected be?
Well, we do generally recommend contingency funds. And what we do is it's based on, right now we're at 30% design. So it's a relatively not fully developed design. So our contingency at this point, we would recommend something 15 to 20% would be typically. As the project gets further designed and we refine what the design is, we hone in on all the details. There's less things that aren't included in our numbers, that contingency usually drops down to 10, sometimes a little bit less than that too.
Can I just mention that I'm quite concerned over what we just talked about a few minutes ago? If you're going to have to come up with more engineering study money to determine whether or not you need sheet pile along the west side, and if you do determine you need sheet pile, I mean, we're talking about a whole bunch more money, and I'm not sure we can really function without knowing what that sum is. You said you were going to send an estimate, but I'm not sure that there's time that would allow that. If I don't know how quick you crank them out and how quickly you'd be taking samples to determine whether that was necessary or not.
Are you talking about the core sampling for that west side?
Yes, and then the ultimate decision as to whether it needs sheet pile or not.
I don't think that's a major cost.
I'm sorry. I guess I'm a little bit surprised it wasn't part of the initial estimate, because we've talked about this sea migration in and out under the parking lot since this came to light, and that's part of it.
Engineer.
Let me weigh in. I think what we're really talking about is the extension on the south side of Allen's building and going up towards the bridge there. And because it was our assumption that EDA would not fund off on private property, we assumed that we'd have to come up with a solution that didn't include that. And then I can't remember who came up with the idea of just using an easement across that, and apparently that will work. So that allowed that to be considered, but really that was never really part of the original cost estimate of the whole project.
Okay. But again, I say if it's something that needs to be done, those numbers have to be incorporated so we understand what the impact is.
You're right.
Yeah, I'll be talking to Mike and to Jan about getting a crew out there again to do those core samples. And I don't think that's going to be cost prohibitive.
The boring part, sure. I think the task that we've got ahead of us is to come up with a decision of exactly what we're going to be doing, so we can give the engineers the go-ahead to actually proceed to final design. And that's a big, we're hoping right now we'd be able to do that, but we've got to step back and think about this a little bit more. And I think, Matt, you're going to be probably talking to EDA relative to the timeframes and all that sort of stuff.
So what are the issues with respect to time frame and lead time and when we can start to do this work? I mean, if we don't make decisions fairly rapidly, do we lose any construction possibilities this season? What are we looking at in terms of time frame, I guess is what I'm asking.
Don, you need to weigh in on what the time frame is for final design once that decision.
Yeah, the final design is going to take us maybe 3 or 4 months, anyways. 4 months, I would say, at least, to get wrapped up and make sure we have everything done. And then,
so realistically, we're not going to start work on this until 2022.
Well, you could do work in the wintertime if you needed to.
Our plans, and I think we're still on track for this. Our plans were to have a final design on a project by this fall, go out for bids this winter, and then be able to start on the project a year from now.
Okay.
Construction. So I think the plan going forward, I mean, and we can, certainly a lot of more time for a common have to chance to absorb all this information. But as I see it, the plan going forward is to start on the plan that describes the bare bones project. We need to do some core samples out and the schooner landing lot, as well as behind the Narragansett Leather Building. And then I plan on talking with EDA and potentially other funders with regard to the flood wall. And it seems to me we build this, if we build this flood wall, it's got to be more than corrugated steel, sheet metal. We've got to have if not a rock facade on it, that it's going to have to be in concrete. But I'm going to work on that.
Well, correct me if I'm wrong, but what I understand is we are short of funds, even with the most minimal application at this point. And I don't think we can hold the project open for a more aesthetically pleasing wall at this point.
Right. Yeah. That's that. Yeah. I haven't. Yeah. I just need to make a few phone calls. The options are here, but you're right. I think we're at a bare bones project that basically achieves the objectives that we've set from the start.
Shit.
I just want to underscore that I believe, from the standpoint of the community, aesthetics are going to be very important. To the point, the stone wall is almost a necessity, I think, in terms of what many people will feel.
Well, I agree, and that's where a fundraising campaign could be started now, explaining that we can't afford to do that. So if you guys want it to be pretty, you're going to have to help us out.
Mm-hmm. Okay.
It wouldn't hurt to, in some way, have a community meeting about this so that the community at large has an understanding and knows where we're at and what we've been doing.
Yeah.
Because I still get questions of, people wondering about what the Waterfront Committee is doing, et cetera. I don't know why we get those, but I do.
No, I think that's definitely in the near future, having a public meeting. It's unfortunate because I think it's difficult to have these remotely, but we need to basically have a conversation where we review what's been designed thus far and get some public reaction.
I agree.
Good. Anything else that anyone wants to mention at this point?
Are we expecting a survey from you, Matt?
Yes, I could put together.
I mean, I didn't know whether it was definite
format.
Okay, I didn't.
Yeah.
Okay, good.
Could I throw out one thing? It's just a real life situation involved. August and I are talking about him purchasing the building. With conventional bank financing now without a wall, flood insurance would be somewhere over 20,000, possibly 25,000 per year, in addition to regular insurance.
So
and that would be true of other buildings in town too, depending on the purchase price.
That's very good information, Alan.
Yeah, well, it points to the urgency of getting this in place.
Yeah.
Anything that's financed through the bank needs insurance on, obviously. So
No.
without having a bundle full of cash, any buyer will be needed to, anything that's financed needs to be insured to that amount.
Okay. That's good. I mean, good information to have. It just adds one more incentive here for us to get this accomplished, and soon.
Well, this was the part of the original incentive for doing this, was to
Sure.
protect all the property values.
Yeah, protect the property values because it has a direct impact on the long-term sustainability of our downtown economy.
Yeah.
Particularly as these properties change hands.
And yeah, it's been in the background from the beginning is getting these buildings out of the floodplain to get that flood insurance cost out of there so that building owners don't start wondering about walking away from their buildings as the water comes up.
Mm-hmm.
Yeah, and I think in the future, the cost for flood insurance is only going to rise as federal government sort of tries to offload the cost onto the individual property owners. So
it took a tremendous, the flood insurance cost took a tremendous hit 4 or 5 years ago down in southern Massachusetts along the coast.
Yeah, Sandy.
Just stunned people.
Oh yeah, there was somebody in New Jersey that had a big house. I think it was going to cost her $50,000 a year for flood insurance. So it's not a small amount.
I know it seems like we haven't ended on a real positive note, but sure are. I hope everyone realizes we're heading in a real good direction here, and finally being able to get down on paper a design that's going to achieve a lot of what this town has talked about for many, many years. So
I think we've moved ahead too with starting to see some dollar numbers in front of us.
Mhm.
Otherwise, it's been really easy to talk about what we want. This gets us into a no pun intended, a concrete situation.
Yep. Very good.
Can I just ask one little question about the water in the parking lot predicament? If there's no retention and the parking lot does flood under these worst case conditions, does that have any impact on whether they can rule the area out of the floodplain or not?
Well, we have a couple different factors coming into play here. One is the long-term impact of sea level rise and water coming over the park and flooding the not only the parking lot but the more frequent concern is the ponding in the parking lot, and that's really not a factor of that anything the wall's going to address. It's a factor of our dilapidated drainage system, and that's a major part of this whole project, is to replace and do it in such a way where we're not getting tide water coming up through the drains into the parking lot.
I do understand that, but my question is, if a building gets damaged by water, whether it's because the parking lot backed up due to rainwater that there was no storage for, or whether it came over the wall, it's still a building in distress. So does that affect the FEMA?
Well, I think to answer that, Doug, Bob Fonts had addressed at the beginning of the meeting the possibility of helping out the two buildings that are probably most at risk with some flood proofing and some door panels and so forth. That would actually, because quite frankly, historically, most of that people bring out sandbags and put them around the door. Some lock, some not. But I think that can be a real solution very short-term, very local solution.
Okay, and FEMA would accept that as a
I
viable
don't know,
solution?
it's
Oh, no.
something.
Well, I think what's, and maybe Jan and Mike can answer this better, but my understanding is the FEMA concern is the tide water rise and the flooding caused by that. I don't know that they have the same, the water sheeting off of Main Street and into the parking lot.
Well,
That's not going to be the determining factor, as I understand it.
I think it still needs to get
and get this
addressed.
condition letter map revision.
I
Go ahead,
think
Jim.
it'll still need to get addressed because it's the total system. So we'll have to
Okay.
at least model it. But the question is, you know, to what degree do you or what storm event do you, how bad do you want to make the rain at the same time there's other events going on to satisfy FEMA? Can you use a smaller storm event so you limit what that storage volume might need to be, or that flooded volume might need to be?
That's another big question that needs to be resolved, because without FEMA's approval of all of this, most of it's a moot subject at this point.
I think their focus is going to be on the protection from the tidal stream and the sea issue, but that's something we'll have to include in the proposal, is how we're going to address the stormwater.
It does seem as though we're coming to kind of a consensus. We need a halfway good looking storm wall. And it sounds as though we've got to seriously find ways to have this water storage system. That's how it's kind of boiling down in my mind. I love the idea of something really pretty and the idea of celebrating the shipbuilding history and all of that. But Damariscotta, it's a little town, but it's really 7 or 8 towns, and we've raised a lot of money for other things. And now all that money didn't just come from Damariscotta. There's a lot of philanthropy around. And despite COVID, I think, especially in the face of this biblical event headed our way, rising sea level, I think it can be. We could come this distance. And, you know, Damariscotta is supposedly setting the pace in this regard. I think we better stick to our guns.
Now, this all the more reason to up our our explanation to the community where we are and what we need to move forward.
That's very true, but the bottom line is we only have X amount of dollars, and if we're going to get the wall built, we have to do whatever it takes to get the wall built, and aesthetics has to follow.
Okay. All right. Well, I will put together a short survey, as just indicated, and get some additional feedback for you. And then we'll reconvene at some future point, but in the schedule, I'm going to set something up for a public meeting as well. Okay.
Good.
All right. Thank you all. I appreciate your time.
Goodbye.
Good to see all your shining faces, even though we have COVID. Some people here I haven't seen for a year or more.
How many people have had both shots?
Yeah.
I have.
So one coming up Thursday.
Excellent. Okay, thanks, everybody. Bye.
Bye-bye.
Take care, Ron.
Thank you guys. Bye.